Without further ado, I'd like to introduce Dean Stahl. Dean has massive industry experience, everything from pharmaceuticals to the food industry. He's also taken 2 companies public and raised hundreds of millions of dollars. Dean Stahl.
Thank you. Well, thanks. Well, before I start, my job is to introduce Mallinda. Before I do, I'll tout CU's prowess here. I graduated twice from this university. Is there a problem with that? Twice before they knew what an entrepreneur was, and decided that all the jobs were in New Jersey or California. So where did I make my home? Right here. Started coming right here in Boulder and been here ever since. So it's a great place. So I'm going to introduce Mallinda. But before I do, a little history will put Mallinda in perspective. Remember an old movie called The Graduate? There's a great line in that movie, which was that the future is plastics. I mean, it was prophetic at the time. I mean, I was probably, 20, maybe. And look at us today. What can you see in your life that doesn't have plastics in it? Where plastics have something to do with how you live your life better? Your car, your computer, your cell phone, your shoes, your pants, your carpet, your clothes, your kitchen goods. I mean, plastics are everywhere. And it's a huge market. Plastics components, those things made from plastics, represent over a $350 billion product category in the United States alone. It's a huge category. But it has a problem. Over many, many years, there's really only 2 kinds of plastics. There's lots of subcategories, but there's kind of 2 kinds. The ones that melt, you make into something, then you can melt them again and make them into something again. And they're usually weak and not very good with temperature deviations, and they're environmentally unfriendly, and they take a lot of energy. The other kind of plastic is hard. You make it once, and after you make it into that shape, you can't use it again. You have to crush it up and take it to a landfill. It's typically where they go. Also energy inefficient and not a very good solution for many things. Now, what would it be like if there was a solution, a new technology, a paradigm shift in plastics technology, where you could take the best attributes of the soft guys and the hard guys and put them into one type plastic? There's an opportunity for that. It's a big opportunity. And now the technology is beginning to evolve to make what I like to call malleable polymers. And malleable polymers are Mallinda. But it's not just that technology. It's the people. There's 3 key players here: Chris, Phil, and we. They've got academic experience that they've partnered with industrial experience and just good, solid entrepreneurial interest and skill. It's a great team. You're going to hear tonight about their first vertical integration of where they can take this first malleable polymer. With all their excitement and enthusiasm, I know there'll be a success. We're going to let Chris tell you all about it tonight. Chris, welcome.
Thank you, Dean. Hello, I'm Chris with Mallinda, and we make better plastic. We have developed the first fully recyclable hard plastic that can be molded and even reshaped with just your hands. So the world is made of plastic. It's in nearly everything that we come into contact with on a daily basis. It's in our clothes, our cars, our homes, our infrastructure. It's everywhere. And you can think of plastic as coming in 2 types. There are hard plastics, which are great due to their strength and durability. But once they're set, they can't be shaped into anything else. They're an environmental disaster. And they're difficult, if not impossible, to repair. There are also moldable plastics, and moldable plastics are great because they can be molded into nearly any shape relatively quickly and inexpensively. But this takes very high molding temperatures, typically upwards of 400 degrees. They're not environmentally friendly, and they're not very strong. Mallinda combines the best attributes of hard plastics and moldable plastics to create one of the most versatile plastic polymers ever developed. As I mentioned, plastic is in everything. It's a $373 billion US market. It's the 3rd largest industrial manufacturing segment in the United States, and that means that there are thousands of applications and dozens of verticals that Mallinda's excited about, such as orthotics, wearables, outdoor gear, do-it-yourself applications like 3D printing, first aid and trauma devices, and personal protective equipment, things like customizable body armor and athletic gear. And I'm sure you guys can think of a million other applications. Let's take a look at Mallinda's beachhead market, the orthotics industry, where we can make an immediate impact. Currently, the process for making orthotics It's time-consuming, it's expensive, and it's inefficient. A patient goes to a podiatrist's office where the podiatrist makes a negative mold of the patient's foot. The podiatrist then ships that off to another office where a technician makes a positive mold of the foot, upon which they vacuum mold plastic at very high temperatures. They attach some padding, they clean it up, and they ship it back to the end user. This can cost patients anywhere from $200 to $800. It can take weeks. And by the way, if this doesn't work the first time, rinse and repeat. We have the solution. What you see here is my co-founder, Philip, and he's molding our plastic directly onto his skin. And what you'll notice is there's no protective barrier on Philip's skin. Our plastic was heated to 175 degrees, and that's about as hot as a hot towel, so it's comfortable. In addition to our relatively low molding temperature, our plastic is 165% stronger than the plastic that's conventionally used in making orthotics. This means that we can eliminate this multi-step, multi-office process and condense it down into one office visit for a faster, cheaper, stronger solution. With downward pressures on healthcare costs, we are perfectly situated to enter this market. We can save patients, we can save insurance companies, and doctors can earn more money by bringing this entire process in-house. So how are we going to make money? Well, Mallinda will start by controlling its capital costs by leveraging our IP through strategic partnerships with companies that have existing relationships with manufacturers and distributors. We'll reinvest our licensing revenue back into our company to build our own manufacturing facility to ultimately direct our own material sales and distribution. We estimate around $4 million in annual revenues in this one vertical alone. People like what we're doing. We've raised $450,000 in non-dilutive grant money for research and development. We've been accepted to a couple of accelerators, and we've won some business plan competitions. And we are the right team to do this. We are all PhD-level scientists. Philip is wrapping up his PhD here at the University of Colorado, and he has 3 years of product development experience with the Fortune 500 chemical company. Wei is a fully tenured faculty member here at CU, and he has extensive experience in patenting his technologies. I earned my PhD at Berkeley and my MBA here at CU, and I have experience in intellectual property and corporate development. In the next 6 months, we're looking to fill our management gaps, complete some third-party testing of our materials, and to begin prosecuting our IP. For this, we're seeking a $250,000 convertible note. And with that, I'd like to leave you with a prescient quote from a classic film, The Graduate.
There's a great future in plastics. Think about it. Will you think about it?
Yes, I will.
Enough said. That's a deal.
Thank you, guys.